Chapter 2 begins with solving equations. The first screen is just telling you the properties and operations that are involved in this chapter. You can go ahead and pause this and read through them. They are ones that we're familiar with. Some of you that had me last year, in 6th grade, you might remember that we did commutative with a big O because commutative meant you could change the order. And we did associative with an ugly C at the end because that meant what was in the groupings were in a different order. So you will see us using both of these properties throughout this lesson. So our first one is going to be 17 plus 36 plus 13. You're going to notice that we have parentheses, so we're going to do that first, is what we are supposed to do for order of operation. However, if I change the order, I can take my 17 and my 13 and put those together. Why would I want to do that? Because that makes a power of 10. So 17 plus 30 gives me 30, so it makes it easier for mental math. I still have my 36, so 30 plus 36, then mentally I can do that, and that's 66. What operation did I do? If I wanted to write everything out, I changed it with the order. I could also say that I changed things with the associative property because I could have changed it to 17 plus 13. Sorry, that's kind of ugly. My 17 is ugly there. And then I added on my 36. That would be an example of associative because what is in the parentheses has a different value. So that's the associative property. If I just wrote it without the parentheses and changed the order, that would be the commutative property. Moving to our next screen, we have 8 times negative 3 times 5. Again, I'm going to change the order, and I see here that mentally I could get a base of 10. So 8 times 5 is going to be 40. And then what I have left over that I didn't use yet, so I changed the order, negative 3. Now this is not associative because I did not have any product or any operation in parentheses. The parentheses there are telling us about multiplication. So 40 times negative 3, and then again mentally I could say that's negative 120. Moving on, this time we're going to evaluate when, so that means I'm going to be doing some substitution. So I'm going to recopy 5. My x is negative 6, and my negative 6 is what is squared. And then that's going to be multiplied by 20. Again, my tops of my numbers aren't working the best. So my next step then, after I've done the substitution, is look to see if there's any mental math that can be done. I'm going to take my 5 times my 20. So I'm changing the order there. That would be commutative. 5 times 20 would give me 100. I can also do my negative 6 times negative 6 is 36. So I can multiply that out. And then I would get 3,600. Okay, you're always looking for a trick to see what you can use to give you some of those zeros on the end to make it into mental math, simpler math that's only to do with one digit. All right, turning to the next one. Again, simplify the expression. This time it's a little bit different. Simplify the expression means we're just going to take some like terms and put them together. You'll notice this is not an equation. There is not an equal sign. So I do have two constant terms, my 5 and my 9, so I can combine those. So my simplified expression would simply be m plus 14. There's no solving involved, just putting together like terms. The next expression, again, we have some constant terms. We only have one variable. We write the variable first. Make sure you're paying attention to the sign here. So that's a positive x. If you can see that, I kind of wrote over the top of it. Let's get rid of some of that. Okay, so that's a positive x. I'm going to put that first. Because it's positive, I don't have to write that in front of it when it starts the sentence off, or the expression off, because it's implied. And then I have a 4 plus a negative 1. So that's going to give me plus 3. And that has simplified that expression then. And moving along quite quickly here, we're going to talk about the properties of addition when they have to do with 0, and the property of multiplication when it has to do with 1. Whenever we add 0 to anything, the number stays the same. Whenever we multiply anything by 1, the number stays the same. Again, if you want to jot these down, you can pause to get those properties down. And our last one is about unit analysis. And you can use unit analysis to find a conversion factor that converts a given measurement to different units. That's the reason that we would use it, if we need to have our answer in a different unit. A conversion factor such as 1 foot over 12 inches equals 1 because both the numerator and the denominator equal the same distance. So you have a fraction that is the same numerator and same denominator, so that's equal to 1 whole. So when you look at the next one, we have our 1 whole here, 1 foot over 12 inches, and then we have our 12 inches over 12 inches. That also equals 1. So the identity property of multiplication tells us that we can multiply a measurement by 1. We've been doing this with other math. You can always multiply by 1 and you'll end up with the same number. So let's put that into effect. We're on the Steel Dragon roller coaster. It's the world's largest roller coaster, and its length is 2,711 yards. How long is the roller coaster in feet? So we want to take what we want to convert, and that is yards, and we want to make that a factor that's going to be equal to 1. So 1 yard is the same as 3 feet, and we're looking for it to change to feet. We can also look at the factor as we can put our 3 feet over the 1 yard. Both of those factors, 1 and 2, are equal to 1 because that distance is the same for the numerator and for the denominator. So what we want to do is cancel things out. And when we're going to cancel things out, we're going to look at that we have the 2,711 yards. And we want to cancel that out with yards, so we're going to put the yards as our denominator. Okay? When we do that, we can cancel the yards out, and now we have the 2,711 yards, and that should be a multiplication there. Change that into a dot. 2,711 multiplied by 3. So if you think of that, each one of those yards has 3 feet in it. So that makes sense. So my answer is going to be 8,133 feet. Excuse me. So once again there, we are going to do the 2,711 times the 3 feet, and that's where I got my 8,133 feet. And of course, because yards are a larger measurement, and we're going to switch them down to feet, we're going to have more feet in that final answer. So if we're going to use that same one to convert centimeters, let's go ahead, and there are 100 centimeters in each meter. Okay, so those equal each other, so those are equal to 1 whole. So we want to change the centimeters. So we're going to go ahead and we're going to do 400 centimeters. We're going to multiply that by a conversion that is equal to 1, and we want to get rid of our centimeters. So I'm going to put my centimeters on the bottom, 100 centimeters, and that's going to equal 1 meter. So as I reduce these, 100 goes into 100 once, 100 goes into 400 4 times, and centimeters goes into centimeters, so that is canceled out as well. So now I have 4 times 1 meter, so that would equal 4 meters. So one more chance on that conversion method. And that concludes Lesson 2.1 on properties and operations.